Internet Information Services, or IIS. Regardless of the approach you use, you can do these installations and configurations with these scripts, and you don't need to log into the instance directly. Here's a more detailed look at metadata. Metadata about a running instance includes information like its availability zone, public IP address, instance ID, and so on. It's accessible from an instance at runtime, and you can use this metadata to configure or to manage the instance. In the example, the metadata is made available at the IP address shown in the curl command. A variable named instance_ID is set by using curl to capture the instance ID using the URL already mentioned. If you use curl to query http://169.254.169.254/latest/meta-data/ while you're connected to an instance, it returns a listing of the available metadata categories. For a full description of EC2 instance metadata and available options, you can search for EC2 instance metadata in the AWS documentation. Next, here's an example of where you could use EC2 instance metadata in a user data script. In the user data script, you can reference the properties of the EC2 instance, including instance IDs, which are not actually known until launch time. In other words, it's possible to query the instance metadata service to retrieve values as part of the variable setting process in the user data script. Here's another example of the curl command, this time showing how to retrieve user data. It's important to know you can also retrieve it by running the describe-instance-attribute AWS CLI command. And now you'll look at using key pairs for remote access. First thing to know is that you should always use public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data, like a password, and the person or entity receiving it then uses a matched private key to decrypt the data. The public and private keys are known together as a key pair. To log into your instance, you need a key pair that is known and registered in the SSH Secure Shell settings of the operating system you're connecting to. And then typically, you specify the name of the key pair when you launch the instance. You can create a new key pair and download it as part of the instance launch process, or when you launch the instance, you can specify a key pair that you already have access to. AWS will handle the process of configuring the instance to accept and recognize the key pair that you specified at launch time for when you log into the instance later. After the instance boots and you want to connect to it is when you use the private key to connect to the instance. Be aware that default SSH settings on Linux instances don't prompt for a password. Instead, they expect you to use a key pair to log in, though it's possible to configure login how you want with custom AMIs. Now, focus your attention on Windows. You'll find that the login process is different, and with Windows instances, you typically use the key pair to decrypt the administrator password and then log in by using Remote Desktop Protocol, or RDP. If you want to know more about EC2 key pairs, search for EC2 key pairs in the AWS documentation. In terms of ongoing security and access, the default administrator password for Windows instances and the EC2 user or potentially other default user password that is set on Linux instances should only be a starting point. It is up to you to define your own instance level security and decide how you will grant or revoke permissions for instance access when people join and leave your organization. For Windows instances, AWS Directory Service can be used to grant and revoke access to machines, and this can be based on already existing Windows users and groups. For Linux instances, there are a number of security options available. Many systems administrators choose to use Kerberos, which is a type of network authentication protocol that uses secret key cryptography for its authentication between clients and servers. Kerberos can be part of a single sign-on solution, or SSO. Other Linux administrators choose to use tools like SSH Keygen to generate their own public and private key pairs for user access to EC2 instances. With this option, the public key details are configured in the user's .sh/authorized_keys file, and then the private key must be made available to the user so they can log in. Ultimately, each AWS customer must choose their own strategy for adding and removing permissions across a fleet of running instances. You could create AMIs that contain all the current users at your company, But this approach can be inflexible and difficult to manage across a few different AMIs. Tools like Chef, Puppet, Ansible, and other configuration management applications can simplify the process of granting and revoking access when you have many machines. And you can often simplify the process to a few commands. You can get more information about manually joining a Linux instance to a Microsoft Active Directory by searching for Join Linux Instances in the AWS documentation. And if you need more information about controlling EC2 operating system access, search for Controlling Operating System Access to EC2 in the AWS documentation. Here's a useful feature. If you want to get visibility into the state of instances, AWS enables you to generate and capture a screenshot of the instance console directly from the AWS Management Console. It's also good to know you can help protect against data loss that might be caused by accidental termination of EC2 instances by enabling termination protection. This feature gives you an additional safety net because you must actively disable or switch off termination protection before the instance can be terminated. Each EC2 instance performs source and destination checks by default. This means that the instance must be either the source or destination of any traffic that it sends or receives. But consider a network address translation or NAT instance. It must be able to send and receive traffic when the source or destination is not itself. So you must disable source and destination checks on the NAT instance. Here's an example AWS CLI command that will launch an EC2 instance. Take a moment to look at all the parameters in the command. You might recognize many of the commands from previous slides. Note that the subnet ID parameter is optional, and if you don't specify the subnet ID, the instance will be launched in the default subnet of the default VPC. Also, it's a best practice to tag your instances. Here, the tag-specifications parameter enables you to apply tags like a name or project code to the instance itself. There are many more parameters and options you can specify when you use the Run Instances command. Thanks again for watching, and see you in the next video. Welcome back. You will now learn some basic tasks for managing EC2 instances. Be aware that instances can be in different states. These include pending, running, stopped, terminated, and restarted. The pending state, as shown in the diagram, is entered by an instance when it's first launched or started. The running state is entered after the instance's operating system is booted and it's passed a couple of health checks, namely the system status check and the instance status check. Depending on the storage type you used for the root volume, an instance can also be in a stopped or terminated state. Now, look a little more closely at this. An instance currently in a running state can be stopped or terminated, but the stop option is only available if it uses an EBS volume for its root volume. This is called an EBS-backed instance. If an instance uses an instance store for its root volume, it can only be terminated, and the stop option is not available. In terms of workflow, the actual termination process comprises the instance first being stopped, and then after that it will be terminated. Also, an instance can be restarted, either from a stopped state or from an already running state. As soon as an instance reaches the running state, the billing for the instance starts. In terms of billing granularity, Linux instances that are launched as on-demand, reserved, or spot instances are billed in 1-second increments, and then other instance types are billed per hour. It's possible to reboot an instance without restarting the billing cycle, but be aware that if you stop and then restart an instance, a new billing hour will begin as soon as it's restarted. If you stop an instance that has a public IP address assigned to it, and you later start it up again, it's going to get a new public IP address. But if you only reboot the instance, it will keep the same public IP address. Elastic IP addresses stay associated with an instance even if the instance is stopped. Be aware that if an instance is terminated, the elastic IP address will then be disassociated from the instance. Certain instance types support hibernation. When you hibernate an instance, the guest operating system will actually preserve in-memory data by persisting it out to disk. Any EBS volumes will remain attached to the instance, and then when the instance is restarted, it gets restored back to its previous state. The RAM contents are reloaded, and the processes that were running on the instance are resumed. And like when an instance is stopped and later started, the original public IPv4 address gets released and a new one is assigned when you restart it. But if the instance is hibernated, it will retain any associated elastic IP address. You're not actually charged for usage for a hibernated instance when it is in the stopped state, but you are charged for the storage on any Amazon EBS volumes, and that includes any storage for the memory contents being persisted to disk. As mentioned previously, instant store volumes cannot be stopped, and they can't be hibernated. To learn more, you can search for Hibernate in the AWS documentation. There are a few things to keep in mind about hibernation. First, to enable hibernation for an EC2 instance, you must configure it at launch time using the AWS Management Console or the AWS CLI. You can't enable hibernation on an already existing running or stopped instance. Next, the instance root volume must be an EBS volume, and it must be large enough to store the RAM contents and your normal expected usage for resources like the operating system or applications. This is because hibernation space is allocated on the root volume at launch to store the memory contents. And finally, hibernation is only supported if the EBS root volume is encrypted, because this helps protect sensitive in-memory contents. This means that when RAM data is written to the EBS root volume, it is always encrypted. This is why encryption of the root volume is always enforced at instance launch. To ensure that the root volume is an encrypted EBS volume, the AMI you use to launch your instance must be encrypted. Be aware that currently the hibernation feature is only available for on-demand instances and reserved instances. It's good to think of EC2 instances as ephemeral resources that you can build up, tear down, and rebuild at a moment's notice. If you're new to cloud computing, this might be a new idea or a new concept. There are many situations in the cloud where you might need to build a new server from scratch. One example might be for automatic scaling, where you might need to deploy new instances without human intervention as part of the scaling solution. For cost savings, you might decide you don't need to keep an instance for the time being, but you do want to be able to recreate it at short notice. For example, batch processing use cases can typically fall into this category. You also might want to downgrade an instance in some way to save on costs. For example, you could downgrade from running the instance on hardware that is dedicated to you as a single customer to hardware that has shared tenancy. Or you might downgrade the size of an instance, for example, from a T2 extra large to a T2 large. Another example would be if the guest operating system of an instance that is running on instance storage is impaired and a reboot does not fix the problem. You might want to discard the instance and create a new one. Another situation might be where you can't log into the instance, perhaps because the SSH key pair was lost or the guest OS was misconfigured. If the instance uses EBS volumes, you might still be able to recover the data by attaching the volumes to a different instance, but you would still probably need to rebuild the server. And finally, you might also need to launch a new instance when you want to upgrade the operating system architecture or the image type. As your needs change, you might find that your instance is overused when the instance type is too small, like when workloads that run on the instance run out of memory, CPU, or disk. You might also find that your instance is underused when the instance type is too large. For example, workloads that run on the instance don't use the amount of memory, CPU, or disk space that was allocated. In either of these situations, the size of the instance can be modified. If a T2 micro instance is too small for its workload, you could change it to an M3 medium instance, for example. First, you stop the instance, modify the instance type, and then restart the instance. When you update to a new instance type, it must support the same architecture. For example, an instance with a 64-bit architecture can only be updated to a different instance type that also has a 64-bit architecture. If the root device is an EBS volume, you can change its size by changing its instance type. Remember that you must temporarily stop the instance to do this. If the root device of the instance is an instance store volume, you must perform a migration of your application to the new instance type that you want to use. The example includes an AWS CLI command that specifies the new instance type as M5 extra large. You can get more information by searching for storage for the root device in AWS documentation. Now we will discuss AMIs. AWS provides managed AMIs, and they include various versions and different configurations of Microsoft Windows Server. To help ensure that customers have the latest security updates by default, AWS keeps Windows AMIs available for 3 months. And then within 10 days after releasing a new Windows AMI, AWS makes the Windows AMIs that are older than 3 months private. After an AMI has been made private, you'll no longer find that AMI in the console, but you can still retrieve the AMI ID via the AWS CLI or SDKs. Amazon Linux AMIs remain available for years. The most recent Amazon Linux and Amazon Linux 2 AMIs appear in the Quick Start area of the AWS Management Console when you choose to launch an instance. You can also query for the latest Amazon Linux AMI using the AWS CLI, as shown here in the slide. Though many instances might be short-lived, some instances can run for weeks or even months. For example, you might have a development and test environment or database servers that must remain stable over time. And in these situations, we recommend that you frequently update the running instance so that it is kept current with the latest security updates. Remember, you own your instances. Keeping them up to date is your responsibility. Windows updates can be installed automatically through Windows Update. You can also choose to disable automatic updates and install the updates manually so that you can test recent updates to ensure that they don't break any existing applications that you're running on the server. Yum, which stands for Yellow Dog Update Modified, is an open source package installer for Linux, and it's based on Red Hat Package Manager or RPM. For Amazon Linux instances, AWS maintains its own Yum software repository, and you can run Yum to install all the latest available updates for all applications that are currently on your server. It can also be used to install updates one at a time if you want to, by referencing specific package names. Also remember that the most powerful tools are AWS Systems Manager and AWS OpsWorks. These services offer features that simplify updating EC2 instances. And the final thing to mention is that depending on the needs of your organization, you could also consider the many third-party configuration management tools that are available. Thanks for watching. See you in the next video. Welcome. In this video, we'll cover securing and purchasing EC2 instances. One of the most important concepts of cloud computing with AWS is the AWS shared responsibility model. One way to remember this model is that AWS is responsible for the security of the cloud, while the customer is responsible for security in the cloud. As an AWS customer, you must secure your applications in the cloud. AWS manages the underlying infrastructure, but you must secure anything that you put on the infrastructure. The responsibility includes securing your EC2 instances and anything that you install on them. You should also pay careful attention to the security groups that allow outside access to your instances, the VPC subnet that the instances reside in, if you use the option, any external access to your S3 buckets, and so on. As such, you must make several security decisions and configure security controls accordingly. Customers are responsible for implementing their own set of controls on everything up from the hypervisor. AWS gives customers security tools, but customers must configure them properly to meet their needs and maintain a strong security posture. For example, AWS cannot perform Microsoft Windows updates for your instances because we have no visibility into the OS layer. Regarding the responsibilities of AWS in the shared security model, your applications and data are protected by highly secure facilities and infrastructure, and by extensive network and security monitoring systems. These systems also provide basic but important security measures, like distributed denial of service, or DDoS protection, and password brute force detection on AWS accounts. When you want to purchase EC2 instances, you have several options. First, you can purchase on-demand instances, and these provide the lowest upfront cost and the most flexibility. There are no upfront commitments or long-term contracts, so this option is a good choice for applications that typically have a short-term, spiky, or unpredictable workload. That could include instances that must only run a few hours a day. You also can purchase reserved instances, and these enable you to reserve computing capacity for 1 to 3 year terms at a significantly discounted hourly rate. These capacity reservations enable you to lower hourly running costs. Be aware that a reserved instance is not a physical instance, but if you expect consistent and heavy use, reserved instances can provide substantial savings over running only on-demand instances. For more information, you can search for AWS reserved instances on the AWS homepage. Next, scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a particular duration over a 1-year term. You reserve the capacity in advance so that you know it is available when you need it. They're a good choice for workloads that don't run continuously, but do run on a regular schedule and take a finite time to complete. Then, spot instances give you access to spare compute capacity in AWS. When you provision EC2 spot instances, you can use the current market rate, or you can specify a maximum bid. Spot instances pricing enables users to realize potentially 70 to 90% savings over on-demand instance pricing. Be aware that in exchange for the cost savings, the instance can be stopped at any time by AWS with only a 2-minute notice. In addition to the optional ways of purchasing EC2 instances, you also have 3 different options for how you choose to run those instances. First, you can run your EC2 instance on a dedicated host. Amazon EC2 dedicated hosts are physical servers that run EC2 instances in a way similar to what you're familiar with, but with capacity that's fully dedicated for your use. They enable the use of existing per socket, per core, or per VM software licenses, including Microsoft Windows Server, Linux Enterprise Server, and so on. The second option is to run your EC2 instances with the Dedicated Instances tenancy option. Dedicated instances and dedicated hosts can both be used to launch EC2 instances onto physical servers that are dedicated for your use. There are no performance, security, or physical differences between dedicated instances and instances on dedicated hosts. But dedicated hosts give you more visibility and control over how instances are placed on a physical server. Finally, bare metal instances provide you with direct access to the physical host while still keeping the benefits of the cloud. While you might opt to run the operating system or virtualization platform of your choice, you can also continue to use features like Amazon EC2 auto-scaling, elastic load balancing, Amazon CloudWatch, and automatic recovery. Note the supported instance type is called i3 Metal. It supports workloads that must access the hardware feature set, like Intel Virtualization VTX, or for applications that must run in a non-virtualized environment, like to meet licensing or support requirements. Direct hardware access also includes use cases like installing your own hypervisor software for a customized virtualization environment, like Microsoft Hyper-V, or for compliance needs. Be aware that spot instances can be significantly less expensive than on-demand instances or reserved instances, but they can be reclaimed from you at any time. There is a spot instance termination notice feature that gives you a 2-minute warning before a spot instance is terminated. You would probably want your applications to use this time for actions like cleaning up current tasks, uploading log files, and doing a more graceful shutdown or termination of the instance. The termination notice itself includes the time when the shutdown signal will be sent to the instance's operating system. Most importantly, it is accessible via the instance metadata after the instance is marked for termination. To get the most use out of the 2-minute grace period, it's a good idea to configure your applications to poll continuously for the termination notice, such as at 5-second intervals. Then when you know termination is imminent, you could begin the operating system shutdown procedure. On Linux machines, this would probably involve hooking into the run levels, and on a Windows, a script could be used. Remember that it is a best practice to encrypt any EBS root volumes especially ones that will be hibernated and have memory written to disk. Thanks for watching, and see you in the next video. It's now time to review the module and wrap up with a discussion of a certification practice exam question. In summary, in this module you learned about Amazon EC2 virtualization. You looked at instance types and the storage options available for EC2 instances, along with the networking components specified when launching an EC2 instance. You now can describe Amazon EC2 user data and metadata and the lifecycle states for an EC2 instance, along with the AWS shared responsibility model. And finally, you learned how to create Amazon EC2 instances. Great work! Now you'll look at a sample certification question. Take a minute to review a sample question that could be on a certification exam. Take a look at this sample scenario and look for any keywords that will help you identify the correct answer. Here, the keywords in this scenario have been highlighted. Take a look at the answer options. Keeping the keywords in mind, look at the answer options and try to rule them out based on the keywords that were highlighted. The best solution in this case is determine the Amazon machine image that will be used. It's time to complete the Module 3 guided lab, Creating Amazon EC2 Instances. It's also time to complete the Module 3 challenge lab, Implement a LAMP stack. Thanks for watching. See you in the next video. Hi. In this module, you'll be learning about scaling compute resources and name resolution. You'll learn about elastic load balancing, how to configure Amazon EC2 autoscaling, and Amazon Route 53. There's also a guided lab for Amazon EC2 autoscaling and a challenge lab where you configure failover routing. At the end of this module, you'll be able to describe the elastic load balancing service and to differentiate between the various types of load balancers. You will also be able to describe Amazon EC2 autoscaling and launch configurations, and how to use Amazon EC2 autoscaling in an AWS context. You will also be able to describe Amazon Route 53 features and routing options. And finally, you'll be able to configure failover routing. You're ready to get started.